So we are going to start the first chapter in the physics. So that is the one-dimensional motion, or you can call it the one-dimensional kinematics. So because you know that physics studies the interactions between the objects, and when the object interact with each other, the motion may change. So first of all, we need to know how to describe the motion using physics quantities or in terms of mechanics. So this is the we will study the 1D first and then 2D, and then we go on to study for relative motion, and then motion with constraints, and then circular motion, and then general motion. Yeah. So actually we may need 2 or 3 weeks. Oh, but actually we need to accelerate a bit. Okay, I think we'll finish it in 1.5 week. So 2 lessons for 1D motion. I mean 2 lessons for 2D motion, and then so we will finish it in 2 weeks. Uh, time is always not in. Time is never enough. So then, first of all, you know that for all the physics term quantities, we can categorize as either the scalar or vector. Okay, I'm not going deep into it because we are talking about it already. Okay, so this is not for GC physics. Okay, but because I think most of you, even for the Form 4 right now, you have not go in deep of this topic. So just go through those basic first, and then next lesson we are going on to do some exercise on this topic. So we know how to do addition, how to do a subtraction. So next lesson, maybe that means a Saturday morning, is it? I forget about what is the starting time. Is it 10 a.m.? So it may be a longer lesson because we may do more exercise on that day. So first of all, we need to define one. Now, to describe the motion, okay. So there are many quantities that we need to use to describe the motion. The first one is the position. The first one is not the displacement. The first one is the position vector. So what does the position vector mean? So let's say this is the uh, coordinate system, okay? And this is the origin of the coordinate. And then let's say this is a point. So at this point, there's a particle there. So position vector is a vector pointing from the origin to that point, okay? So let's say this is point O, this is point P. So position vector is labeled as OP, okay? And then the second term is a displacement. So displacement actually is defined as the change in position. You know this symbol, the triangle means change. So displacement is defined as change in position. So let's say if the particle moves from the point P to point P prime, and then so the final position is OP prime. Then the displacement is actually OP prime, vector OP prime minus vector OP. Or you can also treat it as P prime P. No, sorry, PP prime. So you're pointing from P to P prime. Okay. So the position vector, right, can I change it to now? Yeah. So this is a displacement. Okay, this is a displacement. Sometimes we label it as S. Okay. Distance is another thing. This is the third quantity we use to describe the motion. Distance, we use a symbol D. So distance, the difference between the distance and displacement is summarized in this table. So first of all, when we are talking about the displacement, we don't care about how the object moves from one point to another point. So we just need to know about the initial point or initial position and the final position. So let's say even though the particle is moving along a curve as labeled in the green line, so we don't need to know about the length of this green line, that is the distance. But the displacement, we only calculate the shorter distance from the initial point, initial position to the final position. So that's how we define the displacement. And displacement is a vector. Okay, it points to the direction from the initial point to the final point. That's it. So I think right now it's not too difficult to understand the difference between the displacement and distance. So let's say have a look at uh, this example, exercise 2. So let's say if the spider, is it? Yeah, the spider runs along two sides of a table. So first of all, uh, it moves 0.8 meter north and then 1.2 meter south, east. And then the displacement, okay, the magnitude of the displacement will be square root 0.8 square plus 1.2 square. Okay, that's it. This is the displacement. Let me use a symbol S. If you want to find the direction of it, I think you know how to do it. Okay, just use the trigonometric function. So tangent theta is 0.8 over 1.2, and then you can also express the displacement, the direction of the displacement in terms of the uh, polar bearing or the true bearing. You know about it, is it? So north some angle south or some angle east, something like that. Or you just using one angle, okay? But the angle is measured from the north pole, sorry, from the north to the direction, okay? So you need to use this angle phi as in the true bearing. That's it for exercise 2 is too easy, is it? So I would like you to do the exercise 3. So I would like you to find the magnitude of the final displacement and also find this angle, okay? Also find this angle theta. So I'll give you maybe 4 minutes, okay? Just 4 minutes. I think that should be enough. You can use your calculator, of course. So you give me your answer your calculator, okay? Okay, the length is 74. And to calculate the length, actually you have learned one very powerful tool, the law of the cosine law. So you can consider this as a triangle, okay? This angle is 135 degree. So you can directly use the cosine law. So let's say this side to be c. So you know c squared equal to 30 squared plus 50 squared plus 2, sorry, it's minus 2 times 30 times 50 times cosine and 150, 35 degree. So June, do you do it like that? Or do you do it like that? Okay, June, do it like that, okay? Even you don't know about the cosine law, you should be able to do it by considering this large triangle, okay? So this is a 50 cosine 45 degree. This is 50 sine 45 degree, okay? Then you know, you add up these two sides together and then take the square and then take the square of this side and then the sum of these two equal to c square using the Pythagoras theorem, okay? Then you can find a c and you should be able to do it. And then the angle, you can just use the tangent, okay? The tangent angle equal to, I've written down the length already, okay? So then we'll go on to the next one. So make sure you know how to do it, okay? The next term, after we describe the displacement, the distance, and also the position of the particle, then we'll go on to talk about the how fast they move. So we have two different terms to describe how fast the object moves. So the fourth term is the velocity and the fifth term is the speed. So velocity is defined as rate of change of displacement. A change of displacement, that means a change of position, okay? And then in formula, we could write it like this. So this is a velocity and we can use the triangle, okay? Change in the position. Sometimes for one-dimensional motion, the position is labeled as x. In two dimension, it may be labeled as y. or sometimes the displacement is labeled as s. Okay, but let's consider one dimensional first. So this is how we define the velocity, and then to define the speed, uh, we don't have so many letters in English to for different quantities. For speed, sometimes we still use the symbol v. Okay, instead of changing the distance over changing time. Or whenever you see the term weight of means 1 over time. So weight of energy, that means energy of time. So that is power. So this is how we define the velocity and speed. But because you know the value of the distance and the displacement are different, so therefore the value of the velocity and speed can be different. Okay. And then the direction of the velocity is tangent to the path it travels. So that means it's towards the direction of the motion. The direction of motion, that is the direction of the velocity. Direction of motion. And then let's talk about the unit conversion first, okay? To convert 100 kilometer per hour, well, 1 kilometer per hour to meter per second, first of all, you need to change kilometer to meter, okay? You know it's thousand. 1 hour has 3,600 seconds. And then just simplify it, then you can do the conversion, okay? So we skip these questions, okay? We skip these questions. And then for velocity and speed, actually, they are with there are two different categories. Uh, so we have average speed, average velocity. We have instantaneous speed and instantaneous velocity. So it depends on how what is the time range you are taken. So if it is taken over a time interval, then we use the term average velocity. Instantaneous velocity or instantaneous speed measure the speed of velocity at just time at, and time instant at one moment. Okay, and so that's how we so there are two different terms. So we'll talk about the instantaneous velocity and speed later on. So let's have a look at the few speed that you need to memorize. Okay, for the speed of sound, you need to know about it. That is 330 meter per second, because you need to compare this speed to others. So you know most of the uh, public transport, I can say all, almost all, the speed is less than the speed of sound. And there is some aircraft that can move faster than the sound, but it's rare. Okay, and also the one speed is the speed of light. It has a value that is 3 times 10 to the power 8 meter per second. The B is not an exact value. Oh, sorry. This is just a one off value. Okay, the exact value you can search it in your calculator, and then remember this value because I think you know this value. You learn it in Form 3 optics. So remember this value because when you do some any calculation, the speed of that object cannot be larger than the speed of light. It it may the speed may be larger than the speed of sound, but not 100% should be smaller than the speed of light. Otherwise, you can get the Nobel Prize. So then we'll skip this one, but we'll just do the exercise free and then see who can get the correct answer. So that's your time to do the exercise free. And if you have finished exercise 3, you can do exercise 4. So exercise 4 is just a past paper from the GCE physics later on. So let's talk about the exercise 3. So first of all, we need to know about what is mean by average in physics. Okay, whenever you see the term average, oh sorry, just a second, I get a call. Oh sorry, that's a call. So one of you left. Oh, okay. So never mind. So let's continue. So the term average in physics, it means time average. So it's not just the average of these two values. Okay. So if it is an average of these two values, I give you quite one one I'll give you an extreme case. Okay. So let's say here right here there's a 10 meter. Okay. And here this is 9990 meter. Okay. And a particle moves at 4 meters per second in this range, in this path, and 5 meters per second in the remaining path. So do you think that the average velocity or the average speed is 4.5? Or I even make it to be quite more extreme. So let's say this 1 meter and it is 9999 meter. So do you think it's still 4.5 in average? No. We are talking about the average speed. It means that there is a time average. So that means you need to take care about how many times it moves in this path and how many times it moves in this path. So the longer time or the large time it moves in that path, then the speed will be more heavily weighted. Okay, I don't know if you know about this term. So that may be closer to 5 meters per second in this case. So let's go back to how to do it. Okay, so to do it, so we need to go back to use the formula we have. So the FA speed is defined as a distance over time. So we consider the distance from point A to point B is x, and then this is 2x. Okay, the overall distance is travel is 2x, and then the time will be x over 4 plus x over 5. Is it? When it go from A to B, the time is x over 4, and then when it go back to A, it's x over 5. And then, although you let the unknown x, but it can be cancelled out in later on calculations. So don't be worried that if you need to let some unknowns in the questions, most likely it can be cancelled out later on. Okay, then you get there's 4.44444, okay, meter per second. FA velocity will become zero because displacement is zero because it go back to point A. Okay, so that's it for exercise 3. So exercise 4, you do it by yourself. It's much simpler question. So then let's move on to talk about the instantaneous velocity and instantaneous speed. Whenever you see the uh, word velocity or speed without term FH, it must mean instantaneous. Just give you a Chinese, okay? So instantaneous in Chinese, we use this symbol, okay? So this is the symbol or the character of the eye. So it means when you blink your eye for one time, that time is called this one, okay, in Chinese. So that is around 0.01 second. Well, 0.05 second, I think. But that means it's a very short time, okay? So instantaneous velocity and instantaneous speed, whenever you see just the word velocity, it means instantaneous, okay? So they are vectors. Velocity, sorry, vector and scalar, okay? But the most interesting thing is they have the same magnitude, unlike the FH velocity and FH speed. So for the example of exercise we have done, the FH velocity is not equal to the FH speed in magnitude. But for instantaneous, they are equal to each other. The idea behind is like this. So let's say let me draw a curve. So let's talk about when will the distance equal to the displacement, the magnitude of the displacement. Can you give me anyone knows the answer? So when will these two be equal to each other? And remember how we define the displacement. It is a shorter distance from the uh, initial point to final point. Yeah, they move in. If the object is moving, it's always moving in the same direction. Okay. And in that, along a straight line, of course, in the same dimension, that means along a straight line. Then the distance traveled will be equal to the magnitude of the displacement. But even if it's moving along a straight line, so let's say it go back from A to B and then go back to C, the distance is not equal to the displacement. Okay, the displacement is a length, the shortest distance between point A and point C, and then the distance is AB plus BC. Okay. But how about if we're taking the time to a very short time, or just say at one and at a time instant? So let me draw a curve first. So let's say here is a curve. Okay. So let's say if I want to find the velocity, that means instantaneous velocity or the speed at this time instant. That means that when the particle is passing through the point A. So let me enlarge the graph. Let's see how large I can enlarge. So this is a bit concept in the calculus. Is it? Oh, still that large. Okay. So if you want to find the instantaneous speed at this point, in mathematics, so the velocity is defined as change in displacement over time. You can't take the time to be zero because zero over zero give you undetermined thing or just say math error or something like that. So we need to consider a point very close to the point A. So let me label it as point A prime. And then when the point A prime move closer to point A, that means you take the time interval be smaller and smaller. And then the velocity, what you calculate here is more close to the velocity at the point A. Okay. So that means you are taking the delta t tends to zero, okay, but not equal to zero, tend to zero, but not to zero. When the delta t tends to zero, the delta x, that means the displacement will also tend to zero. So if you look at this path, A and A prime, so this is a very short part of this curve. And then you can see, right now, you can see this is very close to a straight line, is it? It's very close to a straight line. Then we can consider that this path uh, during the displacement from A to A prime is equal to the distance from A to A prime at a very short time interval. That's the idea of the differentiation behind. Okay, if you don't get it, that's fine. So therefore, by looking at the definition, so it is delta x over delta t. This is change in distance over change in time. So these two we consider they are very close to each other. When the delta t is tends to zero, then when we're taking delta t tends to zero, then these two will have the same value. So they have the same magnitude. The velocity is tangent to the path of travel. Okay, that's it. Then, so I would just like to clarify this concept. When we talking about the motion with constant velocity, it means that the object is moving at constant magnitude of the velocity and also constant direction of the velocity. So that means it must travel along a straight line. Okay, because velocity is a vector, so constant vector, the direction does not change. That means the object must move along a straight line. If we are talking about the constant speed, and then the particle should can change the direction of motion or not change the direction of motion. Okay, so that means the path can be either the straight line or a curve. Okay, so we skip this one, then let's move on. I'll skip some of the part because we are not going. Uh, it's not for GC physics. Okay, so for the graph, I hope you read it by yourself first. So let's go to the last term to describe the motion. That is the assertion. Assertion is defined as a rate of change of the velocity. So the A is delta V over delta T. Okay. So V is a you know this formula already. So V is the final velocity and U is the initial velocity, and over time. So this is a vector, and then it has a unit that is meter per second squared. Actually, we can derive it from the formula. The speed has a unit that is meter per second. Time is a unit that is second. So when you divide it, and then you get meter per second squared. And we can look at this formula. It's quite simple, I think. So if we say that the assertion is not zero, we look at the formula. So that means the V minus U is not zero, is it? So that means V does not equal U. So it can be two different cases, okay? If V does not equal U, it can either change the direction or change the magnitude. So that means whenever the object speed, whenever the object's velocity change direction or change magnitude, there is an assertion. And then, just like in a uniform circular motion, the assertion is not zero, okay? Because the object's velocity is always changing. And then if the objects move along a straight line, I just say move along a straight line. I didn't say whether the object accelerates or decelerates. And also I didn't say that whether the object is always moving in one direction. Now in on a straight line it can go forward and backward, is it? So the velocity can change direction and also change magnitude. So the assertion must not it can uh, is not must have zero assertion. Okay. Then let's have a look at this exercise. So I think I haven't teach you in deep. So whenever you see now, in terms of one dimension motion, okay, we have learned the unit vector already. So if it's moving just along one dimension, then we'll just use one the unit vector that's I. Okay. So let's say if the direction is let's say it is positive vi, so that means the object is pointing or the vector is pointing to the positive side of the x-axis. If it's negative vi, that means it's pointing backwards. So whenever you encounter the question with the related to vectors, you need to define the direction first. So let's say most natural way to define the direction is to define positive to the left, sorry, to the right, and negative to the left. Okay. So that means if we want to find the acceleration, so you know the formula, there's v minus u for t. Then the final velocity, okay, the final velocity is it should be plus 4. And then the initial velocity is minus 3 because it's moving to the left. The time is 5. Okay, that's it. Okay, easy. Uh, so let's take a break for 4 minutes, okay? So let's come back at 9:15 p.m. 9:15 p.m. Okay, just take a 4 minutes break. I need. We have talked about all the quantities to describe the motion. Then like, let's relate them by using this summary. Okay. So this is a displacement time graph. Actually, I don't like this term. So most likely, actually, you need to say this is a position time graph. Uh, Now let's say this is ST graph, and then this VT graph, and then this is AT graph. So you know how we define the velocity in terms of the displacement. So that is delta S over the delta T. So actually it means that this is the gradient of the graph of the ST graph. And the assertion is defined as delta V over delta T. So that means the assertion uh, is the gradient of the VT graph. And then, so if you want to find the velocity, so let's say the velocity at this time, so let's say the time 2. Now, remember there's a value of the velocity. This is the value, okay? So that let's say this is 4. So what does the 4 mean? It means the gradient of this point, okay? The gradient of this point. So then how we can find the gradient of this point? If you have this curve, you can do the differentiation. Or you can draw a tangent line and find the tangent of find the gradient of this tangent line. So remember this. And then the next thing is how we can find the velocity in terms of the AT graph or ST graph. So that is the area. You haven't learned about the calculus yet, but the inverse operation of the differentiation is actually the integration. So that is used to find the area. So let's say what does it mean? So for area, of course, we need to take it to be a time interval. So let's say this is 2 and then this is 3. So let's say this area is 2, okay? So what does this area mean? It means that you can have a look here. The velocity has changed. The area of the assertion time graph is a change in velocity. So that means the change of the velocity from the time 2 to time 3 is 2. So that means the velocity changed from 4 to 6. Okay? That's what does it mean by this area. Then we can go on to have a look at some of the exercise up here. So I will just do it faster, okay? I will just do it faster. So I'll just do the example 5, okay? I'll skip describing it. And let's go to part B to find the assertion time graph. So this is the velocity time graph. If you look at the summary, you know that the area means the displacement and the gradient means the assertion. So to find the assertion at the first 8 seconds, so this is a straight line. It's not difficult for you to find the gradient. So it just change in y over change in x. So the change in y from 0 to 8 seconds is negative 12 to 12, is it? Then over 8 seconds, okay? So that's negative 3. So why you can see this is a negative value? Because the 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 slope, the line of the velocity time graph is in is in this shape, okay? You know this shape, it means a negative gradient. And then the total displacement after 12 seconds. Or how can we find the part C and part D together, okay? But be aware that the area can be positive or negative. So this area is positive. We count it to be positive, and this 2 is counted to be negative. So whether it's positive or negative, it depends on whether the curve is above x-axis or below the x-axis. So if it is above, then counting positive, and if it is below, then counting negative. And then let's carry the area first. So you know this how to carry this area. So it's just 4 times 12 divided by 2, 12, 24. So this is the area of trapezium, okay? Uh, I think it is 72, is it? So then how about the distance travel, okay? You For distance travel, you just add these two up together. 96 meter. For displacement, so this 72 you need to take it to be negative because the velocity is always negative in this region. That means the object is actually moving backwards. So and then this is negative 48, is it? So then how can we find the FA speed? Okay, you just divide by 12. That's it, okay? So that's example 5. So then let's move on. Let's move on. You can capture your screen if you like, and then let's move on. So to draw these kind of graphs, I would like to leave it behind after we talk about those equations first. So then. Now you can finish all the exercise in this booklet, okay? In this textbook, and then I'll give you the answer later on. So then we are going to derive the five equations of motion. That means the most important equation for this chapter. Uh, but for this five equation, there are two. You need to the two conditions should be satisfied. Then you can use these five equations. So the two equation is one is straight line. The object must be. Upload this one later on. So the object must move along a straight line. The second one is should have a constant assertion. Okay, you know why after we derive it. So we draw a velocity time graph first. If it is constant velocity, that means it has a constant slope or constant gradient in the VT graph, velocity time graph. Constant slope, that means it must be a straight line. So I assume it to be a straight line like this, and then it has a initial velocity, that is u. Then it has a final velocity, that's v. And then we just use what we have learned. So this area is a displacement, and then this gradient is the assertion. And then we can derive these two equations, okay? The first one is a gradient or the slope. This one is the area. Okay, I think you know how to calculate the area. Okay. And then the other three equations are just derived from these two equations. Okay. You can look at the steps later on, but I'll just let you know the logic behind. So you can see that we have five quantities right now. So to describe using in these equations, time, assertion, initial velocity, final velocity, and the displacement. And then if you look at the first two equations, this equation means the S. This equation, A is missing. So actually, you can derive another three, and you know why. So in each one equation, there is one quantity missing. So in total, there are five quantities. So that means there should be five equations, is it? Five quantities, one equation means one, and then there should be five equations. Therefore, there should be five. And this one is not commonly written in your textbook. It may be useful in some of the Olympic questions, but still you should memorize all of them. Okay, no formula is given in the exam in the commission, and then you look at the derive later on by yourself, and then the most panic thing when you're doing your question is you don't know which equation you should use. But if you have done a lot of exercise, then you should think about the equation in just in 1 second. And then, but this is some tip for you. Okay, so let's say if lah, for all the equation there are four unknowns. So that means the question should give you at least three unknowns, three values. Okay, let's say if give you TAU, then you can find the V. Okay, so that means actually for all the question, you look at the question and then see what quantities are given and then what quantity you are finding. So in total there are three given and one you are going to find. And then in total there are four quantities. And then you just look at the equations here and then to see which one satisfies what you want. Okay, that's it, something like that. So most likely sometimes, okay, the people will call it the Suvat equation, Suvat. And then this one has no S, no A, no V, no U, and no T. So let's have a exercise on some of the questions. Okay, this one. So just give you some idea how to use these equations. So moving from west, that means the initial velocity is 0. And then assertion is 20, so A is 20. The velocity is after 50 seconds. And then you want to find the V. So that means you need to find the equation without the S, is it? You want to, you just get these four quantities. So the one without the S is the first one. That's it, okay? Then you substitute in the equation to get the answer. So let's say this one, traveling along a straight line at 8, accelerate at 1, distance is 18. How fast is it? Eh? Actually, what am I writing here? How fast is it then? I don't know what I'm writing, okay? So how long does it travel? Then that means the time. Then you are going to use the equation that is s equal to ut plus half at squared. If you want to find the v, then you use the v square, you use square plus 2as. Okay, that's it. Uh, all the other questions is something like that. Uh, I will skip the remaining first, and then we spend more time next lesson. So most likely we finish everything we need for one dimension motion, and then we will. I'll send you this note, and then you can try to do all the questions before this Saturday. Yeah, that means you have still have 2 days left. I can also send you some DSC exercise, and then you can have a try. Okay. So on Saturday, let's have a longer lesson. So do you have any questions? If no, then